I'm Beth Pariseau, Senior News Writer at Informa Tech Target, and this is IT Ops Query Season 3, Observability in the Age of AI. In 2020, Matt Young led a coalition of the willing to establish and launch the Cloud Native Computing Foundation's Technical Advisory Group, or TAG, on observability, drafting its initial charter. He still serves as a co-chair for the group. He has also worked as a software engineer at Microsoft, VMware, Red Hat, and Apple, and as a cloud architect and VP at EverQuote. Thanks for joining me, Matt.
Thanks for having me, Beth.
So, you've spent some time as co chair of the Observability Tag, and you've observed the ecosystem grow and change. How do you think generative and agentic AI help observability?
From the perspective of the Technical Advisory Group, for context, this is a group that's part of the CNCF. That's where open source project maintainers and contributors, the builders, vendors, and companies come together to talk about open standards, trends in the ecosystem, and really it's a mixture of a show and tell, as
Right.
well as a, hey, what do you all think about these ideas? Obviously, in the last few years, we've seen in an accelerating crescendo in the last few quarters, not just a lot of buzz and hype, but a lot of actual new core capabilities come onto the scene. Many of these end users have a number of different vendors. Many of those vendors have their own query languages,
Mm-hmm.
their own user interfaces, and they all provide different value, but it can be quite a steep learning curve. And as our systems have grown more and more complex, our tooling's grown more and more complex. And oftentimes, each different tool provides a different vantage point on these systems, but rarely the whole system. So what typically happens, oftentimes the best people that can help you debug stuff historically or that can help understand these are the ones that have been there the longest.
Uh-huh.
That's not my quote. I'll
That's
attribute that to,
charity.
that's a
Yep.
Charity Majors quote, and it's
Yeah.
absolutely right. But the takeaway is that we've demanded that our practitioners are able to build and hold in their brains, in the wetware between our ears, a full view of what the system actually is by assembling it from all of these different signals and different charts and graphs and rates. And as these systems grow more and more complex, this becomes a harder and harder task. And so the number of people that can bring these tools to bear to solve business challenges or maintain systems becomes smaller and smaller. And really, we want that trend to be the opposite, and that is shifting. Well, a very simple example might be I'm using a platform in my company that is comprised of a combination of vendors and spit and bubblegum and
Mm-hmm.
scotch tape in some cases. It's not that far-fetched to say, hey, when I deploy something, I can have someone I can talk to or a resource that I can iterate and have a conversation with to help me understand how to use the tools. What does this system look like? What's going on with this system, or how would I tell? Even in one of the simpler applications of AI and these tools can be just help me onboard to these systems. What am I looking at? Because oftentimes when you're using these systems, something is very wrong, right? Something isn't working and you're in a state of panic. There's oftentimes not someone that you can talk to or not someone that you can talk to quickly. So as a first step, they can be literally an assistant. But I think that a lot more can be done. Much of the focus has been on large language models and conversational chatbots. In my mind, this is scratching the surface. Actually, this is one of the more narrow use cases. In addition to language models, there's other kinds of models that we're seeing. Models that can, for example, generate 3D meshes. One of the things we talked about is what's inside someone's head once they've assembled this rich mental model. In my mind, oftentimes it's more spatial. A workload that's taking up more memory might be a shape, something like a molecule or a space station that takes up volume and has presence. And to parrot another cool quote by Ted Young, we as humans have evolved with a real wild set of skills. We can look at a number of trees and all of their detail and say, that one's got the most apples or pears in it. I'm going to go climb up that one instead of the other two. We
Mm-hmm.
understand the world we live in spatially. It almost seems like science fiction, but what if everything that we're doing now, all of these graphs and charts and 2D representations and web pages and all of the things that we look at are very flat and give us just a slice and then we have to assemble it. What if all of that was just the console of a Star Trek shuttlecraft? And instead of using the console and zooming in and zooming out and holding up rulers to screens, what if I could stand up from it and put on a jet and zoom around my workloads, zoom
Mm,
around my cluster farms, and
mm,
understand them that way and bring to bear what we humans have out of the box? In order to do that, it really gets to how are we visualizing these systems? We can build these
mm,
3D worlds with physics that humans just innately understand to represent a factory or to represent my physical infrastructure. We can do the same thing with digital infrastructure, right? But to do that, we need a way to make it easier
yeah.
to create those experiences,
Hmm.
perhaps on the fly or perhaps using a number of different visual
Mm,
metaphors. The acceleration of being able to generate not just language or code, but to generate other things like 3D worlds or sounds is one kind of not so far away
hmm.
future possibility we have. Those are just two from the practitioner perspective.
Mm. In a recent conversation we had, there's some really interesting technology happening here under the covers. You discussed researching new ideas for observability and data that feeds these AI apps, such as columnar databases and knowledge graphs. And what interests you about those things in particular?
Taken in order, so the reference to columnar data stores or wide table databases have been called, those are actually two slightly different things,
Oh, okay.
but then we could split hairs if we like. But oftentimes, the more detail and the more context that we associate with our data, the more things cost. And it can be a multiplicative cost because of the storage techniques that we've been using. And oftentimes, you end up with just a terrible Sophie's choice, where if I record more context and more dimensionality or have a higher cardinality set, it can be extremely more expensive, but then I need that. So I have to throw away the most valuable thing in order to save money, but you just end up with this constant back and forth. What if we didn't have to make that choice? Columnar stores we're seeing being used. These are things like ClickHouse, Honeycomb, for example, built their own Polar Signals is another observability startup in the space. They've built their own. In the future, I think we're going to see more data stores that aren't bound by either relational models or like a NoSQL model. This is a new underlying storage engine that lets us unify disparate signals. So the third aspect of all of this is, in addition to not having to make choices around cardinality like we have in the past, we can not have to have separate data stores for different telemetry types. The second thing you mentioned, knowledge graphs. Here, this goes. This is actually probably what I'm most excited to see. And if I make a prediction, I think we're going to see a lot more of this. And it gets back to what does all this stuff mean? Knowledge graphs are what you would draw on a whiteboard. Things are circles and relationships between things are arrows. So if you think of that kind of a data model, this is where we get into ontologies or graphs of the types of things that we see in our business, in our infrastructure. So in terms of AI, how do we provide additional context to an LLM? We've seen over the last year or two the notion of RAG, right? Retrieval augmented generation and vector databases. This gets us part of the way there in that you can say, oh, I've got a whole bunch of documents, I've got a whole bunch of information, and I'm going to go look at the thing that I'm asking the LLM, the prompt, and I'm just going to say, what seems like it might be useful? Right. But here we're just doing like similarity searches. But if we really want to have semantic understanding, is this thing a team name? Is it a product name? Is it a new type of infrastructure component? Or is it just something that was made up in a meeting, like a fun code name? Knowledge graphs have a long history, and I don't want to do them disservice. But specifically ontologies, that slice of the science, Microsoft has a project they put out called GraphRag, which sort of uses graphs for that retrieval augmented generation piece using vectors, but also knowledge graphs. I think in terms of helping LLMs make better choices about what they return, anyone who's used an LLM, and hallucination aside, sometimes the nuance and the meaning of what's related to what, not just what's in a document or not, inform those LLMs as they go about what they do now much better. But graphs themselves as a data structure and graph databases, I think we'll also see have a resurgence, because if you think about a Kubernetes cluster and its workloads, all of its pods and deployments and ingresses, if you were to draw a picture on a whiteboard, as everybody does at some point, you end up drawing a graph. But then if you look at a lot of tooling, it's more like tabular data we assemble into that graph, whether it's powering visualizations that provide an easier way for humans to understand things, or whether it's organizing information that is
Right.
itself shaped like a graph. I
It's how
think
we
that
get to that. It's how we get to that Star Trek shuttle view of things.
I
in other
think
words.
so. In
Yeah.
particular, if you're not building a bespoke system. If you want to build a system for industry, for practitioners that doesn't have to know all of the specifics but can figure it out, it's a much harder problem if you don't use that kind of a data model to store information about what's going on. But also, and this is where I think I'm most excited, because all of these large language models are predicting what's the most likely next word, right? At their heart, you could almost think of it as a linear chain of predictions, and everything is built on that. But when you start saying, okay, I have complicated infrastructure, I have a global enterprise, I'm across all of these regions with thousands of machines and hundreds of thousands of workloads or pods. And you can add many zeros to that, actually, two or three for very large enterprises. And all of those things are generating volumes and volumes of telemetry. And again, if you think about it as all these different tables and graphs, it's just a sea of data. But if we're to assemble that into a graph structure, and we're talking here about AI, large language models are one narrow application in the greater universe of graph data science. GNNs, or graph neural networks, supersede. They contain convolutional neural networks and LLMs. And what that branch of science is all about is, if I have a whole bunch of data in a graph, a labeled property graph, as we've been talking about, what's the shape of that graph? And so the patterns and the predictions that they can help us make are really about what's the topological structure of that? What's the shape of our data, if you will? And I think that here now we could have systems that let us run simulations and play games a little more. So imagine a simple app that's got some databases and some caching layers and some load balancers and all of the normal stuff that you would see. And if we connect that as a graph, and we want to start asking questions like, what happens if I make this cache bigger? What happens if I give this database more memory? Much like large language models are doing everything in a straight line and saying, what would be the most likely? What would happen to complex infrastructure that is too big to just reason out? The complex interactions between things. Graph neural networks model that. A good analogy might be from material science, right? If you imagine that every atom in a molecule is a node in one of these graphs, and all of the bonds between those atoms and other atoms are represented by edges, relationships between them. We're seeing advances in medicine and material science because they've been able to apply the same kind of predictive analytics, if you will, but not based on like pure statistics and narrowly looking at a string of numbers that corresponds to memory and saying, how do I extrapolate? But that actually models the interactions between components in these complex systems. Now we can start asking more interesting questions about, or we could actually have these systems do it for us. When I say we, these agentic systems, we can start using the topological aspects, the shape of our infrastructure to help us manage these systems rather than trying something and then seeing what happens or just having these aha moments. We like to think that's an efficient process, but it oftentimes is very much not, right? Um,
At the same
so
time, do you think AI agents are ever going to just replace SREs and developers outright?
I don't think so,
Okay.
because I think a lot of things would have to happen, and we'd have to live in a world I don't want to live in,
Well, okay.
where the robots tell us what to do.
There's that. Yeah.
Oftentimes, to their credit, our SRE teams and teams using observability tooling for businesses that rely on infrastructure, cloud or otherwise, there's just too much importance there. I do think that those teams are going to have, they're going to be supercharged, right? They're going to have these new tools at their disposal. But to say they're going to be outright replaced, I don't know. I do think, though, that they will be more effective. And I would not say a year or 2 years from now that the systems we build are going to be less complex,
Sure.
right? Or smaller, right?
Yeah.
In fact, another way that I think AI and all is going to change that, and again, I'm recalling a recent conversation with Charity, but not just Charity, anyone who's talking about this that I've talked to realizes that we used to live in a software world where most of the packages and a lot of the modules and libraries that are used to build systems are vetted and are hardened and go through many processes. They have communities around them. As a barrier to entry to creating new pieces of software is obviously falling quickly. The need
Hmm.
to understand what's working and what's not, I would
Yeah.
expect to expand.
Well, that's also where you get into things like software supply chain security, which is already a hot topic with lots of fraught discussions in open source. And so then you throw agentic and generative AI into the mix and that rapid generation of code, how do you deal with that?
The process of software is tough. It's getting easier to generate code, but the implications of that are not always captured in what an LLM gives back to you. So when we're looking at solutions that are built with AI at an increasingly rapid pace with less time between ideas and things running, the need to be able to understand these systems is going to be even more dynamic. And I don't want to say chaotic, but it's the Wild West, if you will. So I think that if you look at your typical binary or your typical service, and you look at the dependency graph, you look at what modules are being used by this and what modules do they bring in and what modules do they bring in transitive dependencies. You have a shape of data that's a very rich, deep graph and a very complex system to the point where even understand when you start building these things, the scale of them make our backend databases that are more traditional, like relational data models, cry. They just simply weep.
Yeah.
And much like the data
Right.
stores behind observability tooling, the shape of observability, it's an analogous problem, right? If we say, what is observability tools? What defines them? They are things that help us understand what we've built, right? And so I think that in order to effectively deal with the challenges around software supply chain security, which really you could boil down to what's actually running and is it safe, right? It sounds like such a simple problem, but whiteboards oftentimes aren't enough unless you have a whole room covered in them. I think the data stores behind them and the techniques we use to understand what are the shapes and patterns of things, there are some parallels there, but observability tooling needs to not, it's almost like if you were going to click through and say, okay, this thing is having a hard time, this service, this database, this whatever it is, this is having a hard time. Oftentimes our tooling kind of stops there, but really when big chunks of that come from open source, and that's been the drum of the last decade. Suddenly, is that binary safe? There's all kinds of work that's been done there around vetting it, but when you look into what's behind that binary, the open source project behind it, or the code behind it, you could say what's the code and all of the vulnerability scanning, and it's all amazing and wonderful, but it's people. It's people collaborating that make code. So I think that some of the health of an open source project that created this thing that's one tiny little speck in this giant bucket full of sand. That's really the scale of things if you think about it. Like if you look at a Kubernetes cluster that's not even that busy, just the scale of things that you could go look at, and each one of those things has a whole bunch of people interacting behind it. And so here again, we see what's the interactions between that. How long has this project been around? Many of the metrics that we use are good, like how many contributors does it have? How many stars does it have? But if you think about it, this is really just, these are crude measures. Some of the questions that we need to evaluate how secure or how safe is something or what it's comprised of. Was this made by a person or an ecosystem? What pieces of this thing that is failing was created yesterday by an AI, or what is like a vetted library? Some of the inputs to the decisions about is this something that we need to look at or not, they need to be informed by more than just popularity or stars. And that's not to say that everything that's been going on is the wrong thing to do. Like with certifying things, you could have a whole season and more, right, just on that one topic. But I think that with systems that are best represented by graphs, oftentimes the interesting part is in the relationships between these components and how they're changing over time and the shape of that.
Cool. I think that's a good place to leave it. I greatly appreciate the depth that you get into with these technologies, and knowledge graphs in particular sound like a really exciting and fascinating development.
Yeah, it's one place too where a lot of organizations in the past have built, and today they build knowledge graphs, and they've typically been used to help people find things within their organization, right, or to just build things.
Huh.
And so
Yeah.
there's a lot of existing collateral that organizations have
Hmm.
that I think if observability platforms and systems can tap into that or help companies understand their own nouns and verbs, it makes things more understandable and meaningful and can really help people understand these systems without having to all stop across an organization or go on a fact-finding mission to understand what they're looking at means to the business.
Great. Well, thank you very much for sharing your knowledge today with me. Always great to talk to you, Matt.
You as well. Thanks.
This has been IT Ops Query Season 3 Observability in the Age of AI. If you have any feedback on this episode or want to share questions, comments, or stories we should consider covering, please reach out to me at beth.pariseau, that's PARISEAU, at informatechtarget.com. Please consider rating, reviewing, and subscribing to this podcast on your platform of choice, and tune in next week for our continued conversations with industry experts about how observability is shaping AI and how AI is shaping observability.